Okay, Courtney Fela, this is for you.
Oh, you're recording it?
For Courtney Fela.
Okay, so listen. Can you send it to me and I'll put it on Blackboard on the YouTube channel?
Yeah.
All right. That way I don't have to do this twice. All right, so question 39.
All right, we're flipping. Here we
All
go.
right, so question 39 says that I have, it's this long narrative, right? It says ethanol melts at negative 114 degrees Celsius and boils at 78. Its density is 0.789 grams per milliliter. The enthalpy of fusion of ethanol is 5.02 kilojoules per mole, and the enthalpy of vaporization is 38.56 kilojoules per mole. The specific heats of the solid and liquid are 0.97 and 2.3 respectively. And then they ask how much heat is required to convert 25 grams of ethanol at 25 degrees Celsius to the vapor pressure at 78 degrees. How much heat is required to convert 5 liters of ethanol at negative 140 the vapor phase at 78 degrees Celsius. So there's a boatload of numbers here. It is really hard to keep track of all this. Guess what I do? I draw a picture. I draw a picture, okay? And the picture that I draw, since we're talking about melting and boiling, is a heating curve. What do heating curves look like? Little stair steps? Like that? Okay. All right. What happens here at these sloping steps? No! At these sloping parts? You're heating the particles and making them accelerate. And then when you get to these plateaus, then what happens? You're changing phase. So you're putting in energy to get the intermolecular forces broken. So here you're going to get a subset of the intermolecular forces broken. Here you finish breaking the last of the intermolecular forces. And so then that allows you to go from solid to liquid to gas. All right. This first plateau represents what? Melting. So what's the melting point of this substance? According to that paragraph, it's negative 114. All right? What does the second plateau represent? Boiling. According to this paragraph, how much is that? 78 degrees Celsius. All right? So these numbers are in my picture. They give me a density. We'll use that for something else. Bless you. All right. Let's take a look at what else they say. They say that you have the enthalpy of fusion of ethanol is 5.02 kilojoules per mole. The enthalpy of fusion has this symbol. Delta H FUS, little subscripted FUS. What is this? This is the amount of energy needed to melt this substance. Where am I melting? The first plateau. So that's the amount of energy necessary to get through that part of the graph. How much is that? It's 5.02 kilojoules per mole. So to get through that part of the graph, that's how much energy I would have to enter. All right? Let me explain, guys, and then you guys can ask whatever questions you have. All right. How about the enthalpy of vaporization? The enthalpy of vaporization has a symbol delta H vap. That's the amount of energy needed to vaporize. What's the other word for vaporize? To boil. Where does boiling occur? This second plateau right here. So that requires 38.56 kilojoules per mole. So where am I breaking more intermolecular forces?
You're boiling.
In the boiling process than you are in the melting process. Yeah. So you're basically what is that? Like 7 times fewer intermolecular forces are being broken here than they are there. Okay? All right. Then they give me specific heats. And actually, let me do this in a particular color, so just so to delineate things. So those first 2 numbers are representing the flat parts of the curve. So there, those numbers are in the picture. Then they give me specific heats. What is the specific heat? So the specific heat of the solid would represent that part of the graph right there. All right? So that's the amount of energy that you would have to add to 1 gram of the solid to get it to go up by 1 degree Celsius. And conceptually, really what we're talking about is the amount of energy that I need to get those particles to accelerate to that stage. All right? Because temperature is a measurement of the acceleration of the particles. All right, well, how much is that? 0.97 joules per gram Kelvin. So that's that part of the graph right there. Okay. So the specific heat of the solid, what that represents is the amount of energy needed to accelerate the solid particles to get them ready to melt. All right. And then what about the other number that they give me? So I use that number. The specific heat of the liquid, what would that represent? What part of the graph would that represent? The next sloping bit. All right, so that would be this piece right there. All right, and what is that value? It's 2.3 joules per gram Kelvin. All right, so the specific heat of the liquid is the amount of energy needed to do what?
Accelerate the particles.
Accelerate the particles, but now we're talking the liquid particles. How much bigger is the second specific heat than the first one?
Twice.
About twice as much. Well, why?
You need more.
Needs more energy.
Well, look at the temperature differences. Like, what's the temperature difference to go from negative 140 to 114? How many degrees are you shifting through?
Like 25, 26.
25, 26. Well, how many degrees are you shifting through there? Well, a lot more than 25, 26. Okay. All right. Drawing a picture like this is critical to then going and answering the question. All right. It helps you organize your information. Does that sound like a reasonable thing to do? Same like when we were doing titrations, where I was drawing my little beakers and drawing what was in the beaker and drawing how things pop. I do that all the time. Okay. It is a good skill to have. Let me erase this. I'm going to redraw the graph, and then we'll go ahead and start the question. The question's kind of, there's a lot of conversions. Yeah, Phoebe?
How did you know to start at negative 140?
Well, I'm doing that because they go on and then ask about negative 140 later on.
Oh,
Okay. So, these delta H's represent the energy necessary to break the intermolecular forces. These specific heats represent the energy that you have to add to get the particles to accelerate to get into a position of changing phase. All right? Okay, so let me erase. Just draw my graph again real quick because I need those numbers to be organized. Okay, so this here was 0.97 joules per gram Kelvin. I think it's critical to write units on stuff too. This here is 2.3 joules per gram Kelvin. This plateau there is 5.02 kilojoules per mole. And then this plateau there is 38.56 kilojoules per mole. And let me put the temperatures too on the left, on the y-axis. So this was at negative 114, and this one here was at 78 degrees. Okay, let's tackle the first question. How much heat is required to convert 25 grams of ethanol at 25 degrees Celsius to the vapor phase at 78 degrees? Okay, so they want to know how much energy it takes to go from 25 degrees to 78 degrees. That's what they're asking. Well, where is that on the graph? Well, where's 25 degrees right about?
It's in the second.
Like right in here around? So like from here to there? So basically they want me to figure out how much energy it takes to get through that part of the graph. All right? What are you doing in that part of the graph? You're just accelerating. You're not breaking intermolecular forces, right? So the only constant that you're going to have to use for that question is that one right there, right? What's the variable that you use for this constant? C. What formula do you know has C in it? Q
MCAT.
equals MCAT. All right. So what you're going to do is you're going to use the formula Q equals MCAT.
And solve for C.
No, that is C.
No, I'm saying like rearrange for.
Well, you have to solve for Q.
Yeah.
All right, so now let's take a look. What's M stand for? Mass, do they
Mass.
give me a massive sample that I use? It's
25.
25 grams. What's C?
2.3
2.3
joules per gram.
joules per gram Kelvin.
Kelvin.
What's delta T?
From
78
25
minus
to
25.
25.
All right, grab my calculator. And I get 3,047.5. All right, and it's getting hotter, right? Or I'm adding energy to get it, make it go from 25 to 78, correct? So if I'm adding energy, is that process exo or endothermic? Endothermic, and then I would anticipate that the sign on this answer would be what? Positive. Is it positive?
Yes.
We're good. All right. What's the unit? It's in joules. Because gram cancels out with gram. This is over here in Kelvin, right? Kelvin cancels out with Kelvin. You're left with joules. When you have a number this big,
Wait, I have a question.
Yeah.
It's 78 degrees Celsius. Why does it cancel out with Kelvin?
well, this could be Celsius or Kelvin in that. Because when you do, the difference between 2 Kelvin values or 2 Celsius values is going to be the same amount. Because you add 273 to Kelvin to go from
I'm
Celsius to Kelvin.
stupid. Sorry.
No, it's okay. It's the same. It's the same.
I was just like, meh,
It's the same. Okay.
different letters.
Well, listen, if you were to convert these numbers to Kelvin
Yeah,
and
it'd be the
subtract
same
them,
exact thing.
it'd be
Yeah,
the same
right.
thing. All right. This number's kind of large, so it might be more appropriate to describe it in kilojoules instead. So how many kilojoules is that? It's 3.05 kilojoules if you want to put that way instead. All right. So part A was pretty straightforward. B, however, a little bit more complex. All right. So let's take a look at B. Any questions there? I mean,